Hey guys, we are going to talk about extinction and extirpation today, which follows along with some of the content from chapter 16 and some other content I pulled in for this lecture. So, we know that populations change over time with death and immigration, and they grow through the process of birth and immigration. Over time, when deaths and loss of population members exceed the rate of birth, we may see the elimination of species either from a region or the elimination of a certain population of species, which we know is termed extirpation, and also the complete loss of a species in all populations, representing that species we know as extinction. With or without human interference, extinction has always been a normal process. We know the last dinosaurs disappeared 65 million years ago, and that was more than 60 million years before humans even evolved. Some researchers have looked at what sort of the baseline level of extinction rates are, and the average lifespan of a species is about 4 million years. Based on that, the normal rate of extinction is about 4 species a year as a baseline. But what we see today through what we might call anthropogenic extinctions, or the sixth great extinction event, is that human-caused extinction rates are happening at about 1,000 to 10,000 times that natural baseline rate. And at this current pace, scientists predict that animal and plant populations are likely to become extinct at the rate of about 50,000 species a year during the next few decades. And of course, that biodiversity loss is irreversible. We do know that 99% of all plants and animals that have ever lived are now extinct, and that the process of speciation is still underway and constantly replacing some of those species that have been lost over time. So what is background extinction? We've just discussed the disappearance of species over time at an average rate. We have what we would term mass extinction events. It's been calculated that these happen approximately every 26 million years. And one of those events may have been caused by an asteroid strike 65 million years ago at the end of the Cretaceous. But as you probably read in your book, there's a good bit of discussion still about the causes of some of these mass extinction events. And then anthropogenic extinction is extinction believed to be caused by humans. And these extinction rates could far exceed even some of the worst mass extinctions that we've seen over time. So the book has a really nice figure here that outlines some of those extinction events over time and who was impacted during those events. So again, natural extinction is somewhat balanced by the process of speciation. Sort of that background extinction can be localized. It may be caused by overspecialization of some species. It can be caused by climatic or environmental changes that cause some species to be less adapted to changing or new conditions. It can be from competition of new, more adapted forms of species. Generally speaking, species really constantly and continually have to evolve to keep pace with changing environments over time. Mass extinctions are thought of as worldwide events with a large number of species or even entire taxonomic groups disappearing within an interval of just a few million years. Afterwards, remaining groups tend to undergo a time of adaptive radiation as the extant populations, the ones that are still around and made it through that extinction event, undergo the process of evolution and spreading out and filling some of the niches that have been vacated by those organisms that have become extinct. So some of the greatest mass extinction events occurred in the late Devonian, the late Permian, the late Triassic, and the late Cretaceous periods. Some scientists believe that there is selection pressures that may be changed by mass extinctions. So when the environment changes, it may be that some of the most fit species are suddenly not as fit as they once were, and other species that may have just barely have been hanging on manage to survive and in a sense inherit the earth. And mammals are a good example of this. So mammals originated within 10 million years of the dinosaurs, but for about 140 million years, dinosaurs were the dominant terrestrial vertebrates, while mammals stayed relatively small and inconspicuous in the system, in the ecosystems out there. And most early mammals were small. Mammals most likely began their large adaptive radiation to fill niches that were left open after the demise of the dinosaurs. And the continental fragmentation that took place in the Mesozoic might have also been an important mechanism for diversification of birds and mammals as landforms separated, creating new independent niches on each of those new continents. And that adaptive radiation of birds and mammals occurred rapidly after the Cretaceous and Tertiary extinctions about 65 million years ago. So let's talk through some of these major extinction events that are addressed in your book. So the Permian extinction event was the first really to affect terrestrial life. Of the known genres of tetrapods, there were about 200 in the late Permian, and only 50 of those survived into the early Triassic. We believe that about 80 to 95% of marine species were lost in that extinction event, and about 70% of vertebrate families on land also disappeared. Among those vertebrates, about 78% of reptiles and 67% of amphibian families disappeared during the late Permian. Many paleontologists believe that that extinction event was actually caused by a single abrupt event, something like a mega volcanic eruption or a catastrophic release of toxic chemicals from the ocean depths. We do believe that the world's oceans became anoxic at that time, leading to that profound loss of marine life. Other scientists have actually sort of taken a spin on that mega volcano theory and determined that exactly 254 million years ago, the Earth's crust might have actually sprung a leak, and that crack allowed for molten rock to flow over 2.6 million kilometers in Siberia. That sort of event would have released sulfuric fumes that most likely could have poisoned the atmosphere, the air, and the sea. And huge clouds of carbon dioxide would have then also altered the global climate, leaving a lot of the world's uninhabitable for most organisms. So continuing research and understanding that mass extinction event. The Triassic event, at the family level, the Triassic extinctions were greater even than those of the Permian, with an estimated 80% of all families becoming extinct at or near the end of the Triassic. Scientists believe that extinction was caused largely by the loss of long-established taxa, perhaps in part as the result of the appearance and rapid development of new groups that are adapted to the warmer environment of the Mesozoic period. So during this period, mollusks were decimated, conodonts finally disappeared on land. We had several families of reptiles that disappeared, including ancestors of dinosaurs and crocodiles, and even some of the mammal-like reptiles that existed at that time. The late Cretaceous period led to one of the most well-known mass extinction events, the KT extinction event. It's estimated that about 61% of all tetrapod families became extinct at the end of the Cretaceous period. And 70 to 80% of marine biodiversity was also lost at that time. Some of the extinctions were thought to be the result of the development of better adapted groups as well. While some well-established groups such as bivalves and gastropods and cephalopods and dinosaurs and many marine reptiles were also lost. So this event, the KT extinction event, has been explained by a host of different theories. Really, every conceivable theory has been suggested. And the time that it took for that event to occur varies from weeks to up to 50,000 years. We do know that life on Earth was totally devastated by this event, so it was probably one of the greatest catastrophes in the history of the planet. And the theory for the demise of the dinosaurs are many. We do know that the extinction event was widespread geographically, but there was sort of selection in the groups that were affected. So generally, we saw the disappearance of any land thriving animal more than about a meter long, and almost all the large marine reptiles as well. All flying reptiles were lost, but we did see that most bony fish and sharks and mammals seem to be unaffected by that extinction event. The majority of plant species also survived. And so I encourage you to spend a little more time with some of the theories associated with this event. The one that most people talk about is the meteor impact that would have caused a huge cloud of dust and debris that could have darkened the world skies for 6 to 9 months. This is a nice figure tracing geologic time and some of the extinction events that happened through the eras. And on the left-hand side of the graph, we see number of families represented there as an index for diversity. So what was the role of early humans? Also an interesting and debated topic over the years. So we know that about 13,000 years ago, a massive global cooling kicked in abruptly, leading to the end of about 35 different mammal species, including the mammoth. We know that some believe this was related to a massive explosion or a comet event. There are sediments from 6 different sites across North America that yielded tiny diamond fragments in the soil that generally suggest that those areas were exposed to extreme temperatures. These have been found in Arizona, Oklahoma, Michigan, South Carolina, and Alberta. So during that cooling event, it's believed that some of the first migrants reached the Americas, perhaps via a land bridge, about 15,000 years ago. And within 1,000 years, it's suggested that there were actually people that had made their way into South America. Some of this evidence is backed by the fact that we see characteristics of the first migrants in many Native American tribes, including the Blackfoot, the Sioux, the Cherokee. It's believed that a second migration event might have come 3,000 or 4,000 years ago, and that these people were a mix of Chinese, Southeast Asian, and Mongolian. And they may have come by boat across the Bering Strait. But there's a lot of controversial new research that sort of puts the theory of the timing of human occupation of the New World into question. So paleontologists continue to present evidence showing that there were unspecialized hunters and gatherers that may have been present in the New World at least 25,000 years ago, and possibly as far back as 40,000 years ago. Other scientists, for example, linguists, claim that the diversity of languages that we see through Native people, with over 140 languages that are each as different as English and Arabic, is also contradictory to the concept that we've only had about 13,000 years of occupation. They would argue that it would take more than 30,000 years to derive that many different distinct languages. Some researchers believe that many of the vertebrate species were quickly lost within just a handful of years of Paleo-Americans arriving to North America from Asia. And evidence of that excessive hunting, overhunting, has been demonstrated by some scientists through computer modeling. But again, there's still a good bit of debate about that. Now I'm going to go ahead and cut this recording here, and we'll pick up in the middle of the lecture.